In this video we'll discuss about types of floors between the last level and the attic. The attic roofs, the attic types of attic thermal insulation, types of insulating materials, thermotechnical characteristic of insulating materials, heat flow physics for a specific case, heat flow physics detailed, and calculations for temperature of the attic. Types of attic thermal insulation, good things and bad things for different situations. What is an NZEB building? Map of the world's climatic zones used in this video. Thickness of thermal insulation material for NZEB buildings attics in the fourth situation. Types of floors between the last level and the attic. Wood planks plus wooden beams, concrete plate or metal beams. From a thermal point of view, behaves roughly the same, concrete plate and metal beams. Attics roofs, planks plus wooden beams or metal beams. Attic types, no side walls, with side walls, or attic over attic. From a thermal point of view, it behaves approximately the same as the attics without sidewalls. Types of attic thermal insulation: non-insulated, insulated floor, insulated roof, and floor plus insulated roof. Types of insulating materials: mineral wool, rolls or plates, polyurethane foam, fire retardant cellulose, extruded polystyrene, and expanded polystyrene. Thermotechnical characteristics of insulating materials. Thermal resistance R is with this formula, where D is the thickness of insulating material and lambda is thermal conductivity. Those are the most present insulating material: polyurethane foam with thermal conductivity 0.022, with this thermal resistance for a thickness of 10 centimeters layer. Mineral wool rolls or plates with 0.036, extruded polystyrene, fire retardant cellulose, expanded polystyrene. We see that those four materials have similar thermal characteristics. For polyurethane foam, we will look at fire resistance time, which is small. There are some newer types with medium time. What is the importance of the fire resistance time? Because the most of attics are made from wood, so it is very important the fire resistance time of thermoinsulating materials. Mineral wool has a large fire resistance time. Fire protection is proportional to mineral wool density. Extruded polystyrene has a small fire resistance time. Fire retardant cellulose has a medium resistance time, and expanded polystyrene has also a small fire resistance time. Thermal conductivity of polyurethane foam is approximately 2 times lower than of all the other materials. So at the same thickness, polyurethane foam has a thermal resistance approximate double. For energy auditors for buildings or for people passionate about energy of buildings, in the video description you will find a link to a site about energy performance of buildings, a link to a more simpler video about thermal insulations of attics. Let's discuss a little about heat flow physics. For example, we have a house without attic, only with non-insulating ceiling over the ground floor. Inside we have the temperature, TE 20 degrees. Outside we have the temperature of winter, T exterior, TE 0 degrees. Heat flow from indoor to exterior, from warm to cold, is described by this formula. Heat flow in vat is area divided thermal resistance multiplied internal temperature minus external temperature. I will pass quickly through this chapter. The interested ones can stop video on a specific image and read in the right side more detailed calculation. We see that the thermal flow calculations, we see that it reached a very high value, equivalent of 3.5 radiators of 2000 watts each for a ceiling of 100 square meters. If we add a attic of the ceiling, the heat flow from the interior to the attic through the ceiling is massively reduced. Why this happens? This happens because in the attic the temperature is approximately 10 degrees, and then the difference of temperature between internal and the attics becomes 20 minus 10 degrees from 20 minus 0 degrees, so it reduces at half. This means a flow approximately 2 times smaller than the one without an attic of the ceiling. In this case, the attic, in addition to reducing of about 2 times the heat flow, protects the ceiling and implicitly the entire building. Heat flow ratio with attic divided to heat flow without attic is called the correction factor, and it's denoted with B. To calculate T attic, we set the equilibrium conditions of flows of energy entering and leaving the attic. We have here heat flow between the building and the attic, solar flow through the roof of the attic, internal flow, and the heat flow between attic and exterior, also heat flow through ventilation. This is the equation which describes this physical phenomena. This is an equation of degree 1 with an unknown T attic. If we solve the equation, we get this, where this H is coefficient of thermal coupling between top level and the attic, and this H is coefficient of thermal coupling between the attic and the exterior, including ventilation. Heat flow between the heated area and the attic, unheated, is this formula, but we can express it also as for T interior minus T exterior. We'll multiply with this, which is a mathematical artifice, and we will get this one where B is correction factor for attic and has this formula. Let's see how are made calculations for this ish and this ish. Also for T attic B or ish attic, where ish attic is this ish multiplied with B, we see all those calculations are for this type of attic without sidewalls. We will see different types of attic thermal insulations calculations. First of all is non-thermally insulating ceiling and non-thermally insulating attic roof. We have here each for this from interior to the attic, which is plasterboard, concrete, no mineral wood because it's not insulated. We have those formula d divided lambda, the sum of them. We have here L uncorrected, the area of ceiling divided R uncorrected, and this is this sum. We have here thermal bridges, and we have here C coefficient multiplied with the length of the intersection walls with the attic floor. And we have a total H interior attic L correction ceiling, which is this one. Now we calculate the ish between attic and exterior, the coefficient of thermal coupling between the attic and the outside. We don't have attic side walls, it's zero, the area. We don't have any attic roof isolation, this is zero. We have also a sum of them, resistance, a total resistance 0.367. We divided for L uncorrected the area of the attic's roof divided to the air and obtain this. The area of the attic is, the formula is attic floor divided cosinus of alpha, where alpha is the angle between the horizontal and the roof inclination. And this is the total area of the roof, attic's roof. If we get all of them, we can calculate the attic, B, and each attic. The internal temperature of the attic will use this formula. And we will try an approximately formula for the general public, which is this one. And let's see how it works for January. Let's say we have 20 minus 1.2 divided to, it's approximately this one. In the other month for heating, it's approximately the correct formula. But for the period of cooling, where we have these temperatures, for the heating, we have this temperature, for the cooling, we have this temperature. We see that the sum of them divided 2 is not concording with this one because of the solar flows, which are great because the roof of the attic is not thermo-insulated. And let's see how we calculate the solar flows. We have this formula where it is this thermal resistance of the attic roof, and this is the formula, and we'll take in count also thermal radiation to the sky, and that's why on the month of winter we obtain a -1. Let's see now insulating ceiling, not insulated attic roof. Insulating ceiling with mineral wool thickness 25 centimeters. We have now this is thermo-insulation layer, mineral wool of 25 centimeters. It is in meters, 0.25. We have here the formula, because air is much greater now. We have a much smaller area divided there. We have here plus intersections, thermal bridges with between the attic floor and the walls, and we have a total, each total. And we have also the same situation because the non-insulated attic roof is similar with the other one in the other situation. And we have here no insulation for the attic roof. And we will try this formula, general formula for general public. For winter, this is the formula. We will try to see it here. External temperature -1.2 for Bucharest, Romania. This is a climatic zone 2. And this is heating -1.2 plus 2, let's say it's approximately this one. And for the cooling period, for the summer period, we have 23.4, we have 33.88, but this is the formula for day when the sun is very strong, the solar flows, and this is the formula for night. And let's say it's concordant with the approximate formula. Now let's see non-thermal insulated concrete ceiling and thermal insulating attic roof with mineral wool thickness 25 centimeters. We see here the calculations for concrete ceiling, and with thermal bridges correction. Also, we see here that we have on the roof mineral wool 25 centimeters, 0.25 meters, and this is the calculation that thermal resistance of the roof of the attic becomes much larger. And we'll try this formula, T attic T minus 1 or 2 degrees Celsius, and we'll see here in generally 20 degrees interior. And this one is approximately 18 degrees. This is mean T minus 2 degrees. And also in the um, a month for heating will verify it. It's approximately the correct one. And for cooling, period of the cooling, 26 degrees in interior, we have 26.19 calculation for the attic, but because of the solar fluxes, which are, let's say, important on the summer period, is this correction, and this formula is not exactly. How we calculate solar fluxes? We have this much greater resistance because of 25 mineral wool thickness, and we have also this calculation for each month. Let's see now the situation with non-thermal insulating wood ceiling this time. The thermal insulating attic roof is the same as the previous situation. We see here that we have a greater total resistance of this ceiling to the attic because unventilated air layer, which has this resistance, and we have also planks plus wooden beams instead of concrete, and here is a much lower lambda thermal conductivity, so d divided lambda is much higher, and the total one is much higher. We have also smaller intersection wall with attics thermal bridges, and we have the formula is minus T interior minus 2 or 3 degrees. We see that it's concordant, it's correctly for January, let's say, and also for the heating month, also for the cooling month, the summer month. We see that the formula is not correctly perfectly because of the solar flows, which increase the temperature here in the attic. The last situation, thermal insulating ceiling, thermal insulating attic roof, both with mineral wool of thickness 25 centimeters. We see here a concrete layer ceiling, and we see here total resistance and the thermal bridges and the total one. We see here also to the attic roof mineral wool of 25 centimeters, 0.25 meters. We will try to see those formula if they are correctly. This is the temperature for heating. This is the temperature for cooling. We'll see for generally the formula 20 minus 1.2. That will means divided to approximately 19, let's say, 9.5. This is a little bit gap, but with the other month is the formula will be more correctly. Also in the summer, for 26 degrees on a day, this is the internal temperature and this is the external temperature. The sum of them undivided will be 23 plus 2 or 3 degrees Celsius for the day. For the night, because we don't have solar flow, the formula is identical with the winter one. Types of attic thermal insulation: non-insulating ceiling and non-insulating attic roof. It is the option that should not be taken into account. Heat flow from the heated space to the attic is very large. Insulating ceiling and not insulating attic roof. It doesn't matter if the ceiling to the attic or the attic roof are made of concrete, metal, or wood. The thermal resistance of the insulating layer is much higher than the thermal resistance of the ceiling towards the attic. During the cold period, when the building requires heating, the attic is approximately the exterior plus 2 or 3 degrees Celsius. During the hot summer period, because the roof of the attic is not insulated, the solar flows enter strongly into the attic and produce a strong heating of it, and we have the attic day. It's the exterior plus 10 degrees Celsius during the day, and the attic night is the exterior plus 2 or 3 degrees Celsius at night. If you want to store things in the attics, clothes, furniture, archive, etc., very low temperatures in winter and very high in summer will strongly damage stored things. Temperature in the attic is very close to the outside. Heat flow between the top level and the attic is strongly diminished compared to the variant with non-thermally insulated floor. The decrease is stronger with the increase in the thickness of the insulating layer. Since the temperature in the attic is close to the outside, the heat flow is close to that of an open terrace and therefore requires consistent thickness of thermal insulating layer for the ceiling towards the attic, about 2 times larger than in the case of insulating ceiling and insulating attic roof. This thermal insulating variant is suitable for bridges with low heights that do not allow the usual access of people and no storage. Non-insulating ceiling and roof insulating attic. If the ceiling to the attic is made of concrete or metal, they have a lower thermal resistance. The attic is the interior minus 1 or 2 degrees. If the ceiling of the attic is made of wood, it has a higher thermal resistance. The attic is the interior minus 2 or 3 degrees. Since the temperature in attic is very close to the temperature inside the building, the attic is almost like a heated attic. It is very important that the thickness of the insulating layer is larger than 20 centimeters, for polyurethane foam 10 centimeters, so as not to heat up too much in summer when the solar flows are strong and not to lose much heat in winter, as the case of a heated attic. The heat flow between the top ceiling and the attic is medium, even if the ceiling is not insulated. Because the temperature difference between the building and the attic is small, 1, 2, or 3 degrees Celsius. Even though the heat flow is medium, it is about 4 times larger than the one in the case of insulating ceiling and insulating attic roof at the same thickness of thermal insulation layer. See the right. This thermal insulation variant is suitable for attics with various types of use, gym, hobbyist room, storage space, etc. Insulating ceiling and roof insulating attic. It doesn't matter if the ceiling or the attic the attic or the roof of the attic are made of concrete, metal, or wood. The thermal resistance of the insulation layer is much higher than the thermal resistance of the ceiling towards the attic or of the roof of the attic. During the cold period, when the building requires heating, the attic is approximately the interior plus the exterior divided 2. During the hot summer period, because the roof of the attic is insulated, the solar fluxes almost do not enter the attic and do not produce the significant heat of it, and we have the attic a day is the interior plus the exterior divided 2 plus 2 or 3 degrees Celsius during the day. T attic the night is T interior plus T exterior divided 2 at night. If you want to store things in the attic, clothes, furniture, archives, etc., temperatures are suitable for this. In addition, the moderate temperatures in the attic will contribute to increasing the lifespan of the building materials from which it is made. Heat flow between the top level and the attic is reduced to about half, to the same thickness of thermal insulation of the ceiling, compared to the version with thermal insulating floor and non-insulating attic roof, because the temperature difference between the building and the attic is half compared to that option. It is the variant with the lowest heat flow between the last level and the attic. This thermal insulation variant is the most suitable for attics with heights maximums greater than 1.80 meters. What is an NZEB building? Buildings that meet the condition NZEB, near zero energy building, is a building very well thermal insulated, is what interests us in this video, have very efficient installations for heating, cooling, hot water, ventilation and lighting, at least 30%, which differs from country to country, of the energy needed for building, for heating, cooling, hot water, ventilation and lighting, it's obtained from renewable sources. Currently, all new buildings in European Union must meet the NZEB conditions. These requirements allow us to reduce the CO2 releases that lead to climate change that is increasingly affecting us. Map of the world's climatic zones used in this video. There for different annual average temperature between different temperatures. These are zone 1, zone 2, zone 3, zone 4, zone 5 with different temperatures between them. And you will see what your average annual temperature for your city and see in what zone it is located. Thickness of thermal insulation materials for NZEB buildings attics. Insulation. Insulating ceiling and not insulating attic roof. Thickness were established by me and my fellow energy auditors for building through calculation and experience. For zone 1 is 20 centimeters, zone 2 25 centimeters, zone 3 30 centimeters, zone 4 35 centimeters, zone 5 40 centimeters. If applying polyurethane foam, the thickness will be divided by 2. Non-insulating ceiling and roof insulating attic. For zone 1 25 centimeters, zone 2 30 centimeters, zone 3 35 centimeters, zone 4 40 centimeters, zone 5 45 centimeters. If applying polyurethane foam, the thickness will be divided by 2. For insulating ceiling and roof insulating attic, Zone 1 ceiling 15 centimeters, roof 15 centimeters. Zone 2 ceiling 20 centimeters, roof 20 centimeters. Zone 3 ceiling 25 centimeters, roof 25 centimeters. Zone 4 ceiling 30 centimeters, roof 30 centimeters. Zone 5 ceiling 35 centimeters, roof 35 centimeters. If applying polyurethane foam, the thickness will be divided by 2.